humbled to be included with the rest of the cohort here. Also, I'm just going to apologize in advance for mucking up, which should be a really interesting, fascinating, deeply technical group of talks with a bunch of government flavor. By way of introductions, I'm Josh Finney. I'm from CISA, from the threat hunting subdivision of CISA. I just want to make a quick note that that's pronounced CISA, not CISA or CISA or any of the other things that I hear on a day-by-day basis. CISA is the newest federal agency amongst all of the federal agencies. We still have the new car smell associated with an agency that just came into being a couple years ago, officially in 2020 as part of the Department of Homeland Security. So I presently lead CISA's incident response and proactive threat hunting group, which just as a general note means that when things go bump in the night, we're tasked with figuring out what bumped, what systems were bumped, and in some cases work through the eviction of the bumpers. And if that makes any sense to you, then you're already one step ahead of my extended family and friends when I try and explain what CISA does and their eyes just immediately glaze over. Folks here may be familiar with some of the work that we've done over the course of the years, whether it's in public guidance that we've issued around protecting cloud workflows from advanced persistent threats, whether it's in guidance like SCUBA, where we've worked to create security configuration baselines. You may know our work from activity alerts and indicator bulletins that we put out regularly that describe the nature of the evolving threat landscape. You may also know some of the more recent work we've done in the detection analytics space with the release of the Untitled Goose tool, which is a incident responders companion application for looking at incidents as they happen in Microsoft M365 workloads. We continue on a day-to-day basis to partner with our friends at the NSA, Cybercom, FBI, USG, to identify and disrupt threats and conduct proactive hunts across all 16 critical infrastructure sectors, state, local, tribal governments, and the federal civilian executive branch. I know it's a real popular statement that you've heard over the years that I'm from the government and I'm here to help. And I can tell from the chuckles that everyone knows what that's worth, but at CISA we really do mean it. I think that's worth saying, that it really, there's nothing better for us than being in the space with people who are experiencing the worst day of their professional lives and trying to help them navigate those spaces and get an understanding and be able to get out from underneath it in a way in which they feel like there's really a partner for them in the space. I probably should have checked this. So here's our problem statement. Over the last few years, we continue to encounter identity-related compromises across all of these stakeholder bases. It's worth providing some context to that. CISA works with people of all sizes. So everything from the big distributed enterprise state federal government agencies, places like the Department of State, we're working with some of the best incident responders and threat hunters that we've ever met, all the way down to the smallest municipal water and electric suppliers in Southwest Texas. And as you work with them, there's obviously a lot of obligations there that are very different than a standard IR firm or standard threat hunting firm. And there's an increasingly broad landscape of threats that are aligned against them. And for each of these organizations, identity is just a very different conversation based on their maturity models relative to the system owner's complexity. It gets especially interesting when we start to bake in things like embedded processors, physical systems. We work in places like transportation and rail, in which there's a whole other magnitude of approach that comes in with those type of systems. So first, we've heard from partners that we want to get away from the term assume breach or an assume breach mentality because it's overly pessimistic. So over the course of the day, as you guys talk, if you can help us workshop something that sounds a little nicer, that doesn't sound quite so doom and gloom. I'm very, very eager to hear other people's thoughts on how to call it. In the meantime, we'll just kind of whisper it and just be like, assume breach. Start with an assume breach mentality. But we will continue to work with OMB and our partners in USG to talk about zero trust maturity models and to try and package that problem case up into something that's a more useful mindset. But that's not what we're talking about here. What we're talking about here is that breach prevention mechanisms are not working for us because sophisticated actors are still working across the same places. They still continue to prey on the similar identity-based attacks that we see year over year after year, in which these actors continue to just iterate and change their TTPs by very, very small mechanisms to continue to attack that identity backplane. These threats above all that are up on the board share one common thing. They're just preying on normal traffic. They're preying on normal identity workflows, and they're making detection more and more challenging because everything looks normal, everything looks typical. On a day-to-day basis, you're trying to find the signal in the noise of what is traditional authentication type activity. The recently released blog post in the last week about Storm 558 from Microsoft continue to detail not just these identity-based challenges, but how much it's a shared responsibility space between cloud service providers and the customers and the tenants, and the responsibility that they hold for identifying those type of workloads and knowing what normal baselines look like. For all the events that are up here on the board, I'd encourage you to read the extremely comprehensive blog posts and advisories that both Microsoft and CISA have put out over the previous year. I know the feedback that we've gotten is that we should stop talking about things like SolarWinds. There's a little eye roll in that, like, this is 2-3 years old. We're sick of hearing the same stories. But I think that when we move from a place in which we comprehensively feel like actors aren't utilizing the exact same TTPs that we saw during SolarWinds M365 a number of years ago, that we can stop talking about it. And what we're seeing instead is that actors are using the same TTPs, and that examples like Foggy Web and Magic Web are just the newest iteration of threat actors pivoting just a tiny bit so that they can evade detections that are atomic in nature, and they can continue to consistently approach attacking that identity structure. Most of these briefs over the course of the year, when you go to them, focus on how artificial intelligence and machine learning is going to save all our cybersecurity problems for us. And I'm sorry, that's not what this talk is about. But I am looking forward to that day so that I can pack up the antacids and I can stop worrying about it. So these solutions are solved for us. Transitive identity mapping might just be industry jargon. I'm not sure that it means anything. We've used the language before. It sounds very similar to when my wife, who is a couples therapist, uses terms like, what's your love language? And like, what part of your body do you feel your frustration in? Transitive identity mapping is assumed and processed by our partners in industry in much the same kind of way. It doesn't make any sense. And I'll give you the exact language that CISA has used in some of its advisories around this space. Quote, this is an activity that can be conducted, for example, using a transitive mapping of all potentially compromised credentials to the systems that those credentials accessed. To say that that language didn't resonate with any of our stakeholders is a dramatic understatement. It was mostly met with eye rolls and with, can you please explain that to us, but using different language next time. I think the way we were trying to express at the time, in layman's terms, was once an attacker is able to get privileged credentials to a network, what did they do next, or what could they have done next? Which, when it's said that way, sounds very, very simple, but sometimes, as every NIST document will show you, the most simple concepts are often the most difficult to articulate appropriately. And in the future, we're hoping to envision a future in which it doesn't take a PhD to understand and dissect an attacker's opportunity space and understand what they can reach and what they can't reach. One thing, attackers don't struggle with this concept. The group of individuals you don't see struggling at all with understanding transitive identity mapping are people like our red teamers, our penetration testers, our exploit developers. I'm sure most people expected that in a conference in which we're going to talk about detection analytics, at some point the John Lambert quote about graphs was going to appear on the slide. We've reached that point in the conversation here. But what is not often quoted is what comes after that graphs and lists quote. And that is the follow-on, which says that your network is a directed graph of credentials. You can either see the graph or you can see the exfil. And that is a powerful statement, powerful quote. Attackers across industry for decades continue to use tools like Bloodhound, continue to use tools like CISA's Red Eye tool, which you can find on our GitHub page, to create transitive maps of identity and to create maps of C2 and to be able to understand the ways that things communicate and the core constructs that are involved with them. For decades, attackers have been able to construct an approach that is part of offensive security fabric. It's part of their mentality, it's part of their philosophy. Once they've established a user context for what the boundaries are for access, they're able to expand that, they're able to move laterally, and they're able to understand what they need to touch in order to get to their objectives. From an attacker's perspective, service identities are the exact same as interactive identities, and that's something that on the defender side we struggle to catch up with. So what do defenders need to understand? As network defenders, we need to evolve. We must begin to understand how distributed services API calls, machine identities, network devices, all form a tapestry of communication in distributed systems. We're currently doing it the way you think we are, from lists, from find functions, from individual atomic queries. We're following events in a linear fashion. One of the things I find most interesting is when I watch my incident response teams and my threat hunting teams, and they move away from the scene, they step away, they get on the whiteboard, and they begin to kind of map out what that looks like, what is happening in a user's environment, or with that context of who's doing it. It begins to look very, very similar to what we're describing from an attacker plane. We're beginning to graph, we're beginning to understand the tapestry of communications, and that's when the magic starts to happen. That's when we see the light bulbs start to click on for most folks. So next I want to talk about some stuff that CISA is doing to try and tackle this problem. And it's with a project that we call Pelican. I'll get to the name in a minute. So the first step in the process of understanding graphs was to begin to take a look at how other people across industry were tackling this problem set. We started with Lyft's cartography database. Again, it's on their GitHub page, it's open source. Really, really fascinating case study in how they do that kind of entity node mapping of relationships. We immediately pivoted from there with some of the help from our federally funded research and development centers into looking at how other people understood large chunks of data. Things like, how do we look at protein sequences in DNA? How do we look at social media interactions? How do we model financial markets to understand the movers and the players and the influences there when you have that type of big data at scale? Once we kind of had that understanding of how folks in different industries were tackling this problem, we began to look at the technical approach for this. We began to look at things like Neo4j and back-end data structures that are able to handle this type of complexity and this type of layered graphing information. What we found is that there's almost too much to count in this space. This is a well-understood vendor space and for approaching big data analytics and visualizing it. Most cloud service providers have some sort of a data lake on the back end that they're able to present this information, access it, ETL it, and present it in a way that is meaningful to incident responders and security professionals. So as part of this process, what we learned is that graphs are really powerful. Graphs have a very low barrier to entry. They let us take structured and unstructured data. They allow us to visualize that data in a meaningful way. It works with large data sets and with small data sets, and then it allows us to apply bespoke, custom algorithms to be able to get to a place in which we're able to present that information without the same kind of toil that's required for getting data in and getting data out to linear systems like SIEMs. As a consequence for that, or the benefits of that, is that we are starting to dramatically reduce complexity for incident responders and threat hunters. They can translate deeply nuanced technical information for a broad audience. In some ways, and this is a really bad analogy for it, but it reminds me of in the early aughts when VIPs would come through a SOC and the SOC watchstanders would throw up graphs of IP addresses up on the wall. And so the VIPs would come through and be like, oh, okay, cool, I totally understand what's going on here. In many ways, graphs are doing the same kind of thing. You're able to take deeply nuanced technical information and present it in a way that everyone can digest it. And that's a very powerful tool. So I'm going to start with a case study of what happened when we began to actually use this application and when we begin to plumb a lot of telemetry into a graph and begin to dissect what's going on in it. So we at CISA had an AWS environment that we used for all of our detection analytics, for our threat emulation. It was a test bed for us to run tooling against. And we've been doing that for years before we started using it as an application platform for graphing. And what happened when we started pointing the graphing application at this space is that it immediately looked like what was a sophisticated threat actor living in our environment. And you can cue the alarm bells and the meltdown that comes when you start finding a sophisticated threat actor in your government environment. After the freakouts kind of died down a little bit and we began to dissect what was happening, we pulled apart what looked like thousands of API calls over the course of time from a privileged account and a significant amount of exfil from that same account. When we pulled the details on that, it was because some idiot had installed a project into that same environment that was meant to do the state checking of the AWS environment and to exfil, or not exfil, but to export the key telemetry for that AWS structure, things like CloudTrail, CloudFormation. But this is what it looks like superficially as you begin to address it. Now, did this turn out to be a sophisticated threat actor? No. Did this immediately show us in an operational context of what happens when you begin to plumb this data in and visualize it? Absolutely. It's very easy to see in these types of enterprise environments how that can be a really powerful tool. I also just can't understate here how terrifying this moment was when I was getting those phone calls. Okay, so this is gonna play in the background. This is a small, non-sound related interactive demo of somebody working through the application itself. While this is going, I'm gonna explain why we called it Pelican. As we said earlier with the Untitled Goose tool, we've really stuck to a bird naming convention. I don't know how we got there, but once you've committed to a bit, you have to see it through to the end. And so now we're committed to it. But the reality is that Pelican's actually a great totem for a project like this because Pelican as a bird is known to continue to ingest long beyond the point where it can actually sustain what it's taking in. So for a data analytics platform, it made a lot of sense for us to call it that. And it's also a great euphemism for what most of us are doing at Thanksgiving as we go for plate after plate after plate shoveling food in our face. As you can see from some of the video that was presented here, what we're trying to express here is the reach of identities. So it demonstrates the time lane capacity, how we can sub-select to a specific time frame that we're meant to look at as part of the investigation, zoom in on specific activities, and represent every interactive and non-interactive identity and what was touched. This is a very powerful tool for incident responders to be able to get to that point quickly and easily. So the next question is what's next? What do you do with this once you reach this plane? And the answer is we're going to figure it out as we go, for the most part. Honestly, we're eager to move from a state in which we can visualize everything based on what we know to a place where through semi-supervised graph learning, it's going to begin to label things on its own. It's going to begin to down select the type of information that we want to present to incident responders through some of that semi-supervised graph learning and those neural networks. The next place is we want to be able to layer the information from dissimilar data sets on top of each other so you can do things like identity mapping across different CSPs. We can look at things as they transition from Amazon to Microsoft, from Microsoft to Google, and across all the different SaaS vendors. It's also very, very useful as you plumb in things like Zeek logs, things like Sysmon logs, to be able to provide that multidisciplinary context. Simply put, we're eager to move beyond this state and move on to a state in which threat hunters can focus on the bespoke oddities of an enterprise environment. These are all the things in which every place is unique. This is why is this person doing this? That's ancillary to your policy, to your program, to your rules, to your IAM policies. This is one method that we're trying to tackle this. I'm very, very excited over the next couple of days to see everybody else's ideas of how they're tackling complex ideas, because I think that we are better than the sum of our parts. I think that when we see what other people are working and how they're conceptualizing these problems, immediately, again, those light bulbs begin to flicker. So over the course of the next couple of days, I'm looking forward to meeting a lot of you. I'm looking forward to hearing your ideas, and I'm looking forward to seeing how we can use that to galvanize each other's work and research into a space in which we're a more resilient country. Thank you.